Welcome to 5.04. We're going to determine recursive process and explicit formulas to model given context. So we've looked at sequences now, which are both arithmetic and geometric sequences, and we're going to look at some situations in real life where we can use geometric and arithmetic sequences to model real life situations. So let's go ahead and remind ourselves exactly a geometric and arithmetic sequences are. So pause the video now and just jot down what you remember and the way that you would tell the difference between an arithmetic and geometric sequence. So there's two distinct difference between the two. With a geometric sequence, there's a difference between each term that stays the same. So we're always increasing or decreasing by the same amount. So I like to think of this as either adding or subtracting the same difference, and we use in our definition the variable d to represent the difference. So the same difference between each of the terms. For a geometric sequence, we have a slightly different relationship. So to get from term to term, instead of adding or subtracting the same difference, what we're going to be doing is going to be multiplying by the same number. So there's a common ratio that determines how we move from term to term. So what I like to think about here is that we are multiplying by the same ratio, r, between each term. So if we want to decide which will better model a real-world situation, what we want to do is figure out which of these two situations is going to provide us with an accurate representation of the real-life situation. So when we're looking at problems which involve real-world situations, you want to decide, am I going to be adding or subtracting the same difference each time, or am I going to need to multiply by some constant term, some ratio at each after each set of time, or whatever it is that we're measuring by. So go ahead and copy this one down, pause the video, and try it all on your own without me talking about it. Obviously keep in mind what we just discussed, and then I'll say a few things, but I want to give you an opportunity to try this for the most part on your own. Okay, I hope that went well. What you'll notice here is that there's a big difference between how long it will take you to use a recursive process and an explicit formula. But what's most important to notice here is that we're dealing with a geometric sequence, because after each year we are increasing the percentage that either the US or Asia is consuming. So for the US, each year you are gaining 0.14%, and Asia is increasing by 5.93%. So the key thing to remember here, if you think back to exponential growth, right, I'm increasing by a percentage, and so that means that at each point during when I'm computing how much I've increased, I'm going to have to multiply by this common ratio. So let's just take the US for example and think about the recursive process. So if I want to know for any given year, let's use n to determine the years. So f of n is going to say, let's take the year before, whatever your consumption was the year before, and we'll multiply it by 1 point, and you got to be careful here. So this is 0.014%. So if you think about representing that as a decimal, that is going to be 0.0014, and so it'll be 1.0014. That's what I will be multiplying my previous year's consumption by to get next year's consumption. And so using that recursive definition, we could find the consumption after year 2012 or 2014 or 2015. And in order to do so, we just have to compute all the years previous to that. But what will be more advantageous for us is to use an explicit formula here. And so I'm going to go over how to find the explicit formula for the U.S. consumption and then allow you to find it for Asian consumption. So what we're realizing is that for any given year, N, we're going to take the original amount of U.S. consumption, which was 652.9 billion cubic meters. It's a lot of gas. And we're going to be multiplying it by 1.0014 a certain number of times, right? Because each year, that's what I'm going to multiply by. So if I were moving 5 years down the road, I'd have to multiply it by 1.0014 5 times. So I'm going to take my initial consumption, 652.9, and I'm going to multiply it by 1.0014 n times. Right? Because n is the number of years after 2007. In 2007, this was the consumption. So when n is 0, I want this 1.0014 to be to the 0th power so that I end up with just 652.9 billion cubic meters. And so this is, of course, for n greater than or equal to 0. And that's pretty simple, and this should seem very, very familiar because we've already talked about exponential growth, and now we're building upon our knowledge of sequences to further create formulas to model real-life situations. So go ahead and use this same idea to create an explicit formula for Asian consumption, and then using whatever method that you think is most efficient, try and find when the two will have the same consumption. Okay, so there's a couple of different ways to do it, and I encourage you to come up with the method that makes the most sense to you, and then we can compare various methods on Monday. Once you've done that, go ahead and press play, and we're going to talk about one more example so that we can see what happens when we work with arithmetic sequences. Alright, so this is a situation where we have a college student, or maybe she's a high school student, but she's got kind of a lot of money. She's working with a savings account, and she is depositing a certain amount of money into the account each month. So go ahead and pause the video now and try this completely on your own. Remember, the first step is to figure out what type of a sequence would model this situation, and then to go on and create either recursive or explicit definition, whatever best suits your goal here. So go ahead and give that a try. I'll talk briefly about it, but you should be able to do this one completely on your own. So this is very clearly an arithmetic sequence because the same amount is being deposited into the account each month. So just as an example, if you started with 100 and you were going to deposit 10 each month, you'd have 110, 120, so on and so forth, and the difference between each would be the same. It would be 10. Here we've got to actually figure out what that difference is, and you can use the information given. So after 3 months, there's $1,525 in the account, and after 7 months, there's $1,825. And so that is a change of $300, and that occurs over 4 months. So if you were to figure out, well, okay, how much is going to happen every month, you'd have to take that $300 and divide it by 4. Okay? And so that will be the amount that she's putting in each month. So now I encourage you to think about the two methods, think about recursive and closed form formulas, and explain why one would be more efficient, and then use it to figure out how much you'll have after 4 years. I want you to post in your comment, in your question or your answer, the amount of money that you think she'll have after 4 years. Alright, so make sure you have that in your comment, and I'll see you guys on Monday.